Hi friends, today we are going to see the mechanical properties of the solids. Okay, so now here we are seeing some pictures. Okay, so these are generally known as rubber bands. Okay, you know these rubber bands, and these are some of the springs. Okay, so what is the property of these rubber bands and the springs? Generally, if you stretch these rubber bands, what happens? They will stretch, but after some time if you reveal that force, immediately they come back to their original position. Like this spring also, if you apply force like this, what happens, sir? It will stretch, but after removing that force, once again it will come back to its original position. Okay, so now we are going to see the elasticity. What is mean by elasticity? What is meant by elasticity, sir? So now here if you observe, this is the spring. If you apply force in this direction, what happens? It is the shape of the spring is changing, correct? Whenever you remove that pressure, or whenever you remove that force, what happens? It is coming back to its original position. Okay, so that property is known as elasticity. Okay, so what is meant by proper elasticity? So it is the property of a body by virtue of which it tends to regain its original size and shape. Okay, immediately after revealing the force, it will come back to its original position. Okay, this is known as elasticity. Okay, and here because of this force, what happening, sir? Because of this force, there is some change in this shape. Okay, that deformation is known as elastic deformation. Okay, so now from this point we can conclude what is mean by elasticity and what is mean by elastic deformation. So what is mean by elasticity, sir? Whenever you apply a force or pressure on a material, it will change its shape and size also sometimes. Okay, immediately after revealing that force, it will come back to its original position. That particular property is known as elasticity. Okay, and the deformation is known as elastic deformation. Okay, now if you see some of other materials. Okay, see this is already, you know, this is some clay material. Okay, so what is the property of this clay material, sir? If you apply some force or pressure or something, it changes its shape and remains in that shape only. See, I am so one clay I have taken, and if you observe here, when I apply some force, immediately it is changing its shape. But if I remove that force, it is not coming to the original position. Okay, that so plasticity. What is meant by plasticity, sir? So there are some type of materials. Example, this putty or mud. Okay, if you apply a force on that material, what happens? It changes its shape permanently. Okay, it won't, if you remove, it won't come back to its original position if you remove the force or pressure. That means if you apply force on these particular materials, the deformation caused is permanent. It won't come back to original position. Such type of property is known as plasticity. So what is the plasticity, sir? So plasticity is nothing but if you apply a force on a on some materials, it will changes its shape and shape and size. So it won't come back to its original position if you remove that force. Okay, that particular property is plasticity. That means the deformation caused is permanent. Okay, now you can able to answer two questions. What is the elasticity? What is the plasticity? What is the elasticity? Elasticity means it will come back to the original position after removing the force, whereas the plastic materials, they won't come back to their original position after removing the force. Okay. So importance of elastic behavior. So why we require this elastic behavior of materials, especially in engineering design? Okay. So for example, this is the aeroplane. Okay. So can we design a aeroplane which is very light but sufficiently strong? Okay. So and some artificial limb. For example, we want to design some artificial limb which should be very lighter but it should be stronger. Okay. And if you know this particular shape, where you will find it, sir? So on railway tracks. Okay. Why railway track is particularly on this shape only? Okay. Why a glass is very brittle than brass? Glass immediately breaks, but brass it won't break. It will sag. Correct? So all these questions can be answered only if we know the mechanical properties of the materials, especially the elastic behavior of the materials. Okay. So the elastic behavior of the materials, all especially in solids, okay, we can easily interpret with this particular model. So this model is known as spring ball model. Okay. So by this spring ball model, okay, by the spring ball model, we can illustrate the elastic behavior of the solids. Okay. So generally in solids there are some forces between interatomic. So there are some atoms, you assume these are, so these are atoms or molecules. Okay. There are some forces exist between interatomic molecules. Interatomic molecules are atoms. Okay. So that means in solids, atoms, so each atom is having certain relation or force with the neighboring atoms or molecules. Okay. So they are strong, they are bonded with some force. Okay. If you disturb any atom, for example, if I apply a force on this particular atom, what happens? It changes its position. Whenever it changes its position, the forces between this atom and neighboring atoms changes. Okay. So whenever if you remove this force, immediately because of these forces, this atom will come back to its original position. Okay. So by this model we can easily conclude how exactly elastic behavior, solids exhibit elastic behavior. Okay, sir. So it is simple. In solids there are some forces between atoms or molecules. Okay. Between interatomic, in between atoms or between molecules, they are tightly bonded with some forces. If I disturb any one, any molecule or atom, what happens? The forces around that atom will tend to come back that atom into position after removing that force. Okay. Now we will see the stress. So what is, so you see this is some material. Okay. This is some material. I am applying a force in this direction and in this direction. This is nothing but stretching that particular material. See, this is the example. If you take a rubber band and if you stretch, automatically we are applying force in these two directions. Correct? So here this type of force is known as tensile force. That means if you stretch a body, it is known as tensile force. Similarly, if you compress a body, so I am applying force like this. So I am compressing a body. See, we can see here spring. So I am compressing the spring body. That particular force is known as compression. Okay. So there are two types of forces. One is tensile forces and one is compressive forces. Okay. So stress. So what is mean by stress? So what is mean by stress, sir? So if you take a body, so I am taking a body and I am applying a force on it. Okay, I am applying a force on it. Now what happens? Now this body is under pressure, correct? So this force per unit area is known as stress. Okay, this force per unit area is known as stress. So the restoring force per unit area is known as stress. So stress is also nothing but a force acting per unit area. Okay, clear? So what is the force now? What is the stress now? So stress is equal to force by area. Okay. Next. So stress is equal to force by area. Now, if you see the units, so force is nothing but newtons and area is meter square. So the stress, the units of stress is Newton per meter square or simply Newton m power minus 2, or we can known as pressure. This is also known as pressure. Okay, pascals. So the SI units are Newton per meter square or Pascal. Dimensional formula. So this dimensional formula, if you write, this is ml minus 1 t minus 2. So all these dimensional formulas we have dealt in a separate chapter, dimensions, units and dimensions. Please refer to that particular chapter for dimensional formula. Okay. Now longitudinal stress. So what is mean by longitudinal stress? So there are two types of stress, correct? We have. So now what happens? I am taking a body, I am applying force like this, or I am taking a body, I am applying force like this. Okay, in both cases, I am applying the force perpendicular to the body or along the body direction. Okay, it is away from the body or towards the body. So in both cases what happens, it is changing its shape in lengthwise only. In this case it is compressing, in this case it is elongating. So hence these two forces are also known as longitudinal forces or longitudinal stress. So there are two types of longitudinal stress. One is tensile stress and one more is compressive stress. So tensile stress is nothing but it is stretching the body. Okay, it is stretching the body. In this case, what happens, sir? The length will increase. Next stress is compressive stress. So in this case, the length decreases, correct? The length decreases. See, if you compress a body, automatically its length decreases. So longitudinal stress. What is mean by longitudinal stress, sir? There are two types of longitudinal stress. One is tensile stress and one more is compressive stress. In both cases, the length going to change. In one case, the length increases and in the case, the length decreases. Okay. Next, strain. What is meant by strain, sir? Now, whenever you apply a force on a body, automatically what happens? It changes. Okay, it changes its length depending upon the force. The length may decrease or the length may increase. Okay, so so in this so now we can conclude, we can define the strain. It is the ratio of change in length to the original length. Change in length to the original length. For example, in this case, I am applying a force like this. Because of what? Because of this, what happens? It changes its length. Okay. So now this is delta L and this is original L. Now what is the change, sir? This is the change. Okay. Now strain is equal to what is the formula? Delta L by L original length, delta L by original length. Okay, so what is the definition? Strain is nothing but it is the ratio of change in length to the original length. Okay, so it in another way it indicates how much the object is deforming, how much percentage the object is deforming. Okay, now we are going to see the longitudinal strain. So already we know uh, longitudinal stress. What is the? There are two types of longitudinal stress. Correct. One is tensile stress and one is what is that, sir? Compressive stress. Okay, so because of tensile stress we will get tensile strain. So in this case what happens, if you stretch a body length will increase. So compressive strain, in compressive strain length decreases. Okay, so in this example we are clearly going to see what is force. So see, I have taken a body like this, okay, with the length L naught. Okay, now I am applying a force in this direction and in this direction. That means I am compressing it. Whenever you compress it, automatically what happens, its length decreases. So here delta L is the change in length. Okay, delta L is the change in length. So now bar is under compression, so it is the compressive force. So automatically we will get compressive stress. So what is the stress formula? It is force per unit area. So F by A, let A is the area of this bar, correct. Now the length, change in length is negative because it is decreasing, correct. So change in length is the L2 minus L1, delta L is L2 minus L1. So L2 minus L1, that means what, sir? So here L2 is less, L1 is more, so automatically change in length is negative, so the compressive strain is negative value. So delta L by L naught. Okay, and in this case if you observe, this is the, what is this, a tensile force. It is, I am stretching the body. Whenever you stretch the body, what happens, the effective length increases by delta L. Okay, in this case the final length is more than the initial length, correct. So the body is under tension, so here we will get tensile stress and the formula is F by A. Now the tensile strain is change in length by original length, that is delta L by L naught. Okay. Now we have seen the longitudinal stress. Some cases what happens? So now if you observe this body, this is the cube. Okay, sir. This is the some solid body which is fixed at the bottom side. Okay, which is fixed at the bottom side. Now I am applying a force tangential to the upper surface. Okay, previously we have applied a force in this direction. Now we are not applying force in perpendicular direction, we are applying force in tangential direction. Whenever if you apply such type of force, now what happens, see here, these two opposite faces, I am applying a force like this and like this. Okay, now because of these two forces, what happening, see the body will get deformed like this. This upper plate and lower plate, they are shifting their positions. Okay, so with the delta L, previously they are under same. Okay, same. Okay, there is no difference. Now there is some shift between lower plate and upper plate. Okay, so this particular stress is known as shear stress, or it is tangential forces. This stress is due to tangential forces, hence it is known as tangential stress or shearing stress. Okay, so simple, there are two bodies. One body is moving like this, one body is moving like this. Now the stress at this point is known as shearing stress. So whenever two forces acting on a body in different directions, okay, then that body will undergo which force? Shear force. Okay. See, we will see some other examples also. Now I have taken a cylinder of length L. Okay. Now I am applying two forces on the top. One force is like this, and at the bottom one force is in opposite direction, but both forces are tangential in direction. Now because of this, what happens? The top plate, the top and bottom, they are displaced with some length that is known as delta x, and the angle with vertical is also known as theta. With angle theta, now this top plate is displacing. Okay, we can observe this in our everyday life also. Okay, if you take a big book and if you place that in a on floor, now if you push that upper part of the book like this, what happens? There is same this upper paper will displace with the lower paper with an angle theta. Okay, so here also the force is shearing force. Okay, so one more example. So now in this case the body is fixed at the bottom. Now I am applying a force in this direction, tangential direction. So automatically the upper plate and lower plate, okay, the upper plate moving in the direction of force with respect to uh, uh, lower plate, okay, by delta x. Okay, some length, some displacement, some minute displacement, or we can tell it as theta also. Generally it should be 0. Now they are displacing with they are making some angle theta. Okay, now tangential stress or tangential shearing stress. Okay, so it is also stress. Generally stress means, so stress is nothing but force by area. Stress is nothing but force by area. So simple concept. Here the force is shearing force or shearing stress. Area is common only. So the shearing stress or the shearing force or tangential force per unit area is known as shearing stress. Okay. Now stress is equal to force by area, but in this case stress is shearing stress and the force is shearing force. Okay, as usual the stress is having same units, that is Newton per meter square or Pascal. Now shearing strain. So as usual, so whenever we apply a stress, automatically there is change in position. Because of that, what happens? Strain will come. So this is the body. Whenever you apply a force in this direction, the top, okay, the top plate moving by delta L. What is the change in length now? This is delta L. So what is the strain formula? Strain is equal to change in length by original length. Okay, the original length is L naught, the change in length is delta L. Okay, we are taking here tangential direction. Okay, the movement in the tangential direction. So S is equal to, what is the formula? Delta L by L naught. So it is defined as the ratio of relative displacement of the faces. So between these two places, so this is one face and this is second face. These two faces are displaced by delta L or delta X. So it is the displacement delta X to the length of the cylinder or length of the body. Okay, so shearing strain. Now the shearing strain is nothing but delta L by original length L. So we can name it as tan theta also. So what is the tan theta? Now this is the theta. Generally tan theta formula is opposite side by adjacent side, that is delta L by L naught. So in this case what happens? This is nothing but tan theta. Okay, so shearing strain, simply what is the shearing strain means? It is tan theta. Okay, so generally the shearing strain, this theta is very less for the solids. Okay, it is less than 10. Okay, so the theta for up to 10 degree, the tan theta is directly equal to theta. Okay, so we can tell that shearing strain is nothing but, so we can tell that shearing strain is also is equal to tan theta. Now how many formulas we will get? So shearing strain is equal to, first formula is change in length by original length, or we can name it as tan theta, or directly we can say it as shearing strain is theta. Okay. Next, there are some type of pressures. Okay, hydraulic stress. So now this is the, you assume this is the ball. Okay, now if I am keeping this ball under some water or some pressure. Okay, under some water, now almost around this body, what happens, some pressure is coming. Okay, because of this pressure, what happens, the effective volume of this body changes. So previously this is the original volume. Now because of this force, it is reducing its volume. Okay, so you take one more this. Now this is the cube. Now I am applying pressure in all directions. Okay, now I am applying pressure in all directions. So because of this, what happening, the total shape is changing. See, this is the bigger one. Whenever I am compressing this body in all directions, what happening, the effective volume of the body decreases. Here it is not changing the shape, its volume is changing, correct. Here it is this is a ball only. So this ball is changing, it is not changing its shape, it is reducing its volume. So here also this cube, it is reducing its volume. So this is some pressure. So hydraulic stress, so hydraulic stress, the internal restoring force per, here also, here also we are applying force. So force per unit area is known as hydraulic stress. So the internal restoring force per unit area is known as hydraulic stress. Okay, it is nothing but pressure. So pressure per unit area, sorry, force per unit area. What is the pressure? Pressure is equal to force per unit area. Okay, so generally where we will get for example, this is the sea. Okay, inside the sea I have dropped a ball. Okay, now this ball is having, see, everywhere this wall is facing some pressure, that is water pressure. Okay, now hydraulic or volume strain. Okay, this is strain produced due to hydraulic pressure. So in this case, what is changing? In this case, effectively the volume is changing. So here it is also known as volume strain, correct? It is also known as volume strain. So what is the volume strain? Change in volume by original volume. Okay, so hydraulic strain is also known as volume strain. Okay, sir, volume strain. And generally strain don't have any units. Okay, because we are volume by volume. So volume by volume, volume means gets cancelled with volume units. So generally strain, whether it may be longitudinal strain or shear strain or uh, or volume strain, so they don't have any units. Now we are comparing stress with the strain. So what is mean by stress? So stress is nothing but force per unit area is known as stress. What is strain? It is change in length to the original length is known as strain. Okay. So generally stress is denoted with some, this symbol sigma. Okay, this symbol sigma, whereas strain is denoted with C, this is E. Okay, this symbol generally. So what is the formula for stress? It is nothing but force per unit area. Now here, what is the strain? It is change in length by original length. Okay, the units of the stress is Newton per meter square, and the strain don't have any units. Okay, it is unitless quantity. Okay, and here, if you observe these two lines, the stress can be exist without strain. So, for example, this is the body. Okay, now I am applying a force. You take steel. Okay, I have applied only less force, so there may be change in length or may not be. Uh, the body may compress or may not compress. Okay, strain may be there or may not be there. Okay, so stress can be exist without strain. Even though there is no deformation, we okay, the force exists. um, for example, uh, okay, stress can exist. So after applying a force, some minimum force is required to deform this material. Okay, until that it won't deform. Correct. So stress is exists even without strain, but when a body changes its length means there should be definitely some force. So strain cannot exist without stress. Okay, so we have seen various types of stresses. One is tensile stress, compressive stress, shear stress. Okay, and volume stress also we have seen, and hydraulic stress. There are so the corresponding strains also there: tensile strain, compressive strain, shear strain, and volumetric strain.